3. I/ATLAS, the third interstellar object ever spotted from Earth, is currently speeding through our solar system. Astronomers managed to capture it live, streaming the event to viewers worldwide. Researchers were left stunned by what they uncovered. According to reports, Loeb has even warned people to brace themselves. The bold claim is that this comet could carry alloys that don't exist on Earth. It may sound unbelievable, but the evidence isn't easy to dismiss. Data from the Very Large Telescope in Chile suggested that its gas plume contained nickel without iron, chemical markers that look industrial, and a path that defies chance. This is where the mystery truly begins. Here's the twist. It's not what you might expect. So, let's get straight into it. When astronomers first detected 3 I/ATLAS in the summer of 2025, it quickly became clear that this wasn't just another comet. Its movement across the night sky revealed something unusual, instantly setting it apart from the countless icy bodies that pass through our system. This wasn't a comet shaped by our sun's pull, nor an asteroid from the debris between Mars and Jupiter. It was an interstellar visitor, the third of its kind ever seen, and its sudden appearance raised questions that scientists still struggle to answer. The name itself, 3 I/ATLAS, is telling. The 3I shows it's the third confirmed interstellar object, following 1 I/Oumuamua and 2 I/Borisov. Both had already rewritten what we thought possible about objects entering from deep space. But 3 I/ATLAS was on track to be different. It was discovered by the 3 I/ATLAS survey telescope, a reminder of how crucial all sky surveys have become in catching these fleeting cosmic travelers. Unlike asteroids locked in repeating orbits or comets that revisit every few decades, 3 I/ATLAS entered on an unbound path. It came from elsewhere, and once gone, it would never be back. What stood out even more was the orbit it cut across our solar system. It wasn't just hyperbolic. It was hyperbolic to an extreme, far beyond that of any other known object. It was moving too fast to be trapped by the sun's gravity, destined only to pass through. Astronomers found that its eccentricity was the highest ever recorded, making escape certain. But the real puzzle was how closely its path lined up with the ecliptic plane, the thin slice of space where all major planets orbit. The odds of such a precise alignment happening by chance were calculated at less than a fraction of a percent. It almost seemed intentional. Atlas captured the strange duality of interstellar discoveries. The excitement of seeing something entirely new, mixed with the unsettling fact that we know so little about what drifts between stars. At first, it seemed comet-like. Early images showed a faint coma, a tail of gas and dust released as the sun warmed its surface. But soon, details began to raise doubts. The dust looked oddly spread. The gas jets weren't typical, and the way its brightness changed puzzled astronomers. With observatories across the globe locked onto it, 3 I/ATLAS was already proving it wouldn't fit into neat scientific categories. To grasp the significance, remember that only a few of these interstellar visitors have ever been caught during human lifetimes. Each one is like a messenger from another star system, a frozen sample of chemistry and history from worlds we may never reach. 3 I/ATLAS offered scientists a chance to study material created far beyond our sun, possibly carrying hints of planetary systems with very different pasts. That alone sparked huge excitement across the scientific community. Yet underneath that excitement was growing unease. If the orbit was so unusual, and the chemistry turned out to be stranger still, what exactly were we looking at? Was this just another comet with oddities? Or was it something that stretched the very definition of a comet? These questions loomed while astronomers gathered their first data. No one wanted to make rash claims, but no one could ignore that 3I/ATLAS wasn't behaving like a typical comet. What made this case even more striking was its timing. Humanity was still wrestling with the mystery of Oumuamua, which didn't act like a comet or an asteroid. And now 3I/ATLAS had arrived, bringing its own list of anomalies. One unusual interstellar object might be chalked up as a fluke. 2 in a row could be chance. But 3? That was starting to look harder to wave away. This was the stage for the first close studies of 3I/ATLAS, a hyperbolic stranger with a suspiciously aligned orbit, a dust cloud that broke the rules, and chemistry waiting to be revealed. Whatever the final answers would be, one thing was certain. 3I/ATLAS wasn't here to slip quietly into the background of comet science. It was here to raise questions humanity may not be ready for. And as you'll soon see, those questions only grew stranger with each new observation. As the first wave of data came in, astronomers focused on the comet's chemistry. Interstellar comets are rare chances to examine material from beyond our star, and their makeup can reveal how and where they formed. In this case, telescopes worldwide, from the James Webb Space Telescope, JWST in orbit, to the Very Large Telescope, VLT in Chile, turned their instruments on the visitor. What they discovered was so unusual that it instantly marked 3I/ATLAS as different from anything seen before. The VLT delivered the biggest shock. Its readings picked up nickel vapor in the coma, the faint cloud of gas and dust surrounding the comet's core. Finding nickel was already unexpected, but what truly shocked scientists was the lack of iron. Normally, comets release nickel and iron together, since both are locked into similar minerals. But in 3I/ATLAS, nickel was present in large amounts, while iron seemed almost absent. This imbalance was no small detail. In planetary science, element ratios matter. And when a basic relationship, like nickel to iron, breaks down, it forces researchers to reconsider their models. The findings hinted that nickel-rich compounds were being released by processes that didn't affect iron the same way. Such a separation is rare in nature, leading some to suspect the comet's chemistry might point to something never seen before. The James Webb Space Telescope added more insight. With its advanced infrared sensors, it detected that 3I/ATLAS was mainly releasing carbon dioxide. Along with that came smaller amounts of carbon monoxide, water, and carbonyl sulfide. While these gases aren't unheard of in comets, the overall mix was unusual. Together, the data revealed a comet whose chemistry didn't match the patterns built from decades of studying comets in our solar system. It was as if 3I/ATLAS had formed in an environment with completely different conditions from the ones we know. Adding to the puzzle, scientists also detected cyanide emissions, another marker that behaved in unusual ways. Both nickel and cyanide levels rose sharply as the comet drew closer to the Sun, far more aggressively than in most comets. This rise suggested a strange sensitivity to sunlight, with 3I/ATLAS releasing these compounds at rates that were difficult to explain. For planetary researchers, these findings raised serious questions. One idea was that nickel came from fragile organic materials containing nickel that were broken apart by solar radiation. Another proposal was that sunlight triggered photochemical reactions in dust grains, releasing nickel atoms while keeping iron locked inside minerals. Still, neither explanation fully matched the steep rise or the sheer volume of nickel being observed. By now, it was clear that 3I/ATLAS was not just another icy body. It carried a chemical profile unlike any comet studied before, a fingerprint pointing to processes and conditions outside the normal boundaries of our solar system. The unusual mix of elements only added to the mystery that had begun with its strange path through space. For astronomers following the data, one point became unavoidable. 3I/ATLAS was forcing them to rethink what interstellar objects might look like. Once the shock of the nickel detection settled, astronomers worked quickly to find natural explanations. Science usually starts with the simplest answers, and several possibilities were considered. One suggestion was that nickel was bound in delicate organic molecules that easily broke down under sunlight, allowing nickel atoms to escape while iron stayed trapped in sturdier minerals. Another idea involved photodesorption, where photons knocked nickel atoms off dust grains without disturbing the iron. A third thought was that exotic nickel-rich organics could be breaking down under heat, releasing nickel while leaving iron behind. Each of these possibilities sounded plausible, but none sat comfortably with the data. Nickel and cyanide production were rising at extremely steep rates as 3I/ATLAS approached the sun. In other words, instead of gradual increases that could be expected from simple heating, their output spiked dramatically, following power laws far sharper than any typical comet. That sort of behavior doesn't match what we'd expect from basic sublimation or mild reactions. Something else seemed to be at work. The absence of iron made the puzzle even harder. Nickel and iron are normally found together in space. They are forged together in stars, spread by supernova, and seen side by side in meteorites that fall to Earth. To see nickel without iron and in such large amounts went against the standard models of cosmic chemistry. Some scientists argued that iron, being less volatile, might simply not have been released yet, while nickel escaped more easily. But if that were the case, why was there so much nickel? And why did its release grow so sharply with solar distance? Cyanide added another layer to the problem. CN has been observed in comets before, but in 3I/ATLAS, it appeared to rise in tandem with nickel, as though both were tied to the same mechanism. That connection was difficult to explain with normal chemistry. If organics were breaking down to produce cyanide, why would nickel appear at the same time? It suggested something more organized than random destruction of comet material. The scientific community debated heavily. Some pointed to unusual ices formed in environments not yet studied. Others thought surface chemistry could amplify nickel release under solar heating. Yet every proposal came with gaps. No single explanation tied all the data together. 3I/ATLAS seemed to be following rules that science hadn't yet written down. This was where frustration began to grow. With two earlier interstellar visitors already defying neat categories, many hoped 3I/ATLAS would give clarity. Instead, it added more confusion. If anything, it suggested that comets in our solar system may not represent what exists across the galaxy. Other regions could produce completely different chemistries, giving rise to behaviors we struggle to explain. By this stage, researchers faced an uneasy truth. Natural explanations existed on paper, but none of them were fully convincing. The anomalies refused to disappear, and as more data came in, 3I/ATLAS resisted being placed into known categories. And just as conventional answers began to fail, more provocative voices entered the discussion. When results showed nickel without iron, it didn't take long for Loeb to comment. Loeb, a Harvard astronomer known for pushing boundaries, had already stirred debate years earlier by suggesting that the first interstellar visitor, Oumuamua, might have been alien technology. His stance has always been straightforward. When evidence does not fit natural explanations, don't immediately dismiss bolder ones. To many scientists, this approach is irritating. To others, it's exactly the sort of open-mindedness that science sometimes needs. In the case of 3I/ATLAS, Loeb saw hints of something less like nature and more like industry. The fact that nickel was released without iron suggested a selective process. On Earth, there is one place where nickel is separated so cleanly: industrial refining. One specific method, the nickel carbonyl process, converts nickel into gas while leaving iron behind. The similarity was striking. Loeb wrote about it directly, noting that the chemical signature of 3I/ATLAS mirrored a process already known in human factories. Still, he chose his words carefully. He didn't claim the object was an alien refinery or a craft made of unknown alloys. Instead, he described it as a signature worth considering, one that resembled industrial activity more than ordinary comet chemistry. In his view, the odd composition raised questions that deserved to be asked, even if most astronomers hesitated. Could 3I/ATLAS be shedding material shaped by something like manufacturing? And if so, what would that mean for its origin? Loeb also floated other bold ideas. In one essay, he suggested 3I/ATLAS might be nuclear-powered, creating light or releasing dust as part of propulsion. He speculated that what looked like comet dust could actually be exhaust collected from long interstellar travel, rather than simple ice sublimation. He did not present this as fact, but rather as a challenge to think beyond standard comet physics. For Loeb, anomalies were not problems to explain away, but chances to test if our assumptions were too narrow. Naturally, his comments drew pushback. Astronomers like Samantha Lawler and Chris Lint argued that 3I/ATLAS displayed all the hallmarks of a comet: dust coma, volatile gases, and solar-driven activity. They warned that jumping to ideas of industry or spacecraft was closer to science fiction than astronomy and risked distracting from real testable science. Still, Loeb's influence was undeniable. Each time he spoke or published, the debate grew louder. Media outlets often seized his remarks, turning them into flashy headlines about aliens, even when Loeb himself had not gone that far. Some critics accused him of chasing attention, while others noted that science moves forward by at least considering uncomfortable possibilities. Loeb himself defended his position by saying that extraordinary discoveries call for extraordinary openness. Ignoring anomalies too quickly, he argued, might cause us to overlook the one signal that could change everything we know. In the end, Avi Loeb placed himself as something of a provocateur in the ongoing scientific discussion about 3I/ATLAS. While many tried to force the nickel anomaly into established chemical models, he asked whether the real question was about technology. Where most people dismissed the trajectory alignment with the ecliptic as coincidence, he wondered if it was intentional. And while mainstream voices urged restraint, he leaned into speculation, not to claim certainty, but to keep possibilities open. For those following the case, this was the moment the story shifted. The comet was already unusual, but now a well-known astronomer was suggesting that its behavior looked less like something shaped by stars or planets and more like something that could come from factories. That kind of suggestion demanded attention. Whether people agreed with him or not, Avi Loeb once again ensured that an interstellar visitor would not disappear quietly from the headlines. Instead, 3I/ATLAS became the focus of controversy, with its chemical signature fueling a debate that was as much about imagination as it was about hard science. The buildup around 3I/ATLAS had already been significant, but the controversy came into sharp focus when Avi Loeb's remarks were tied to a striking headline: "People should be prepared." 3I/ATLAS contains alloys unknown on Earth. According to reports, this wasn't meant as a literal claim that brand new metals had been found. Rather, it was a way of capturing Loeb's central idea. The chemical fingerprint of 3I/ATLAS looked oddly similar to the results of industrial refining, not to natural comet activity. And as Avi Loeb himself emphasized, it's not what people might think. What he actually wrote was much more cautious. He pointed out that the nickel without iron pattern resembled byproducts from processes such as the nickel carbonyl method, which on Earth is commonly used to isolate nickel gas while leaving iron behind. In industry, that step is routine, a standard way to produce alloys with specific properties. Finding a similar chemical signal coming from an interstellar comet was, in his words, extraordinary. It was not proof of alien technology, but it did mean that brushing off the anomaly without serious thought would be careless. Loeb's suggestion was straightforward. If something in nature looks industrial, it's worth asking why. This is where the phrase, "it's not what you think," takes on meaning. Loeb wasn't saying that alien civilizations had left spacecraft filled with exotic alloys unknown to human science. He was saying that the chemical separation seen in 3I/ATLAS paralleled processes we already understand. Parallels that are difficult to explain with standard comet theories. The real risk, he argued, wasn't that the public would immediately jump to aliens, but that scientists would refuse to even consider the anomaly. The strength of this framing was that it pushed both sides, the mainstream and the speculative, to sharpen their reasoning. For those insisting 3I/ATLAS was just a comet, the nickel anomaly required a better explanation. For those open to the artificial possibility, Loeb's comments gave scientific weight, not proof, but a reminder that evidence must be followed, even when it points in directions that make people uncomfortable. Media outlets latched onto the idea of alloys that don't exist on Earth, even if that wasn't exactly what Loeb had said. The phrase captured public attention, turning what might have been a technical discussion of vaporized nickel into a story with existential undertones. Were we seeing traces of alien industry? Or was this simply a comet formed in conditions different from anything in our solar system? By the time this stage of the debate closed, the fine details mattered less than the sense of possibility. 3I/ATLAS was no longer just an interstellar object moving away into the void. It had become a mirror of our own curiosity and the limits of our understanding. The headline may have overstated things, but at its core, it reflected a message Loeb himself would not deny. People should be ready for the idea that some interstellar objects might carry signatures we can't easily explain with natural processes. And while it might not mean what most assume, the very fact that such a discussion is happening shows how much 3I/ATLAS has shifted the conversation. The aftermath of a mystery. By the time 3I/ATLAS began to fade into the distance, the scientific argument it sparked was still alive. On one side stood mainstream astronomers, pointing to dust, gas release, and volatile chemistry as proof that the comet still fit natural categories, even if it was unusual. On the other side stood Avi Loeb, and others willing to consider that the anomalies might point to something more. The real divide wasn't about what 3I/ATLAS was, but about how far science should go in entertaining possibilities that sound extraordinary. The aftermath highlighted something deeper about how we deal with the unknown. Headlines amplified Loeb's words with talk of alien alloys and technology. But beneath the noise lay a genuine puzzle. The separation of nickel from iron, the sharp scaling of cyanide, and nickel emissions and the strange trajectory alignment with the ecliptic, remain unexplained by normal comet models. Whether 3I/ATLAS was artificial or not. It showed how little we truly understand about interstellar objects, and how each one has the power to challenge assumptions we didn't even know we had. For the public, the story was a reminder that even the most powerful telescopes can only go so far. Without a spacecraft nearby, data remains open to interpretation, and interpretation invites speculation. Loeb's voice stood out because he refused to shut down possibilities, insisting instead that anomalies must be followed, even if they touch on ideas that feel uncomfortable. His critics countered that too much speculation risks overshadowing real science, making the public see every comet as a potential alien craft. Yet perhaps that tension is exactly what gives discoveries like 3I/ATLAS their power. They show that science depends on curiosity, but also on skepticism. Without both, anomalies either get ignored or blown out of proportion. Atlas revealed how fine that line really is, and how quickly a rare cosmic traveler can ignite debates that go far beyond astronomy. As the object drifts away into interstellar space, one fact remains clear. 3I/ATLAS has left an impact. Not because it delivered definite answers, but because it raised the kinds of questions that linger long after the comet itself is gone. Questions about chemistry, industry, technology, and whether we're ready for the possibility that one day a visitor from beyond might carry evidence that changes everything. What about you? Do you agree with Avi Loeb, or do you have your own theory? Share your thoughts in the comments.